In this video, we briefly introduce our manifold-aware deep clustering, which can enhance hyperspace utilization more effectively than the original deep clustering. First, deep clustering is one of the very famous methods for monoid speech separation. It estimates a high-dimensional embedding for each time frequency bin of an input spectrogram. Two embeddings come to be close to or far from each other depending on whether they belong to the same speaker or not. In deep clustering, the embeddings belonging to different speakers locate orthogonally. This means that deep clustering limitedly uses a part of the embedding space. For example, it utilized 1/4 for 2 speakers and 1/8 for 3 speakers as shown in these figures. Here, the remaining space should be used to improve performance. To utilize the whole embedding space, we maximize the target angle based on the number of speakers. This is the key idea of a method. These are the results of quantitative comparisons. As shown in this table, you can see our manifold-aware deep clustering outperformed the original deep clustering in almost all cases. This is an example of the results of qualitative comparisons. This is the input sound.
The female produces a litter of 2 to 4 young in November and December.
Ashland is expected.
These are the results of the original deep clustering.
The female produces a litter of 2 to 4 young in November and December.
When its initial public offering is completed, Ashland is expected.
Next, these are the results of our manifold-aware deep clustering.
The female produces a litter of 2 to 4 young in November and December.
When its initial public offering is completed, Ashland is expected.
You may hear the improvements. We added the spectrograms of the ground truth. Also, you may see the improvements at places that have been circled. Our manifold-aware deep clustering has many other interesting characteristics. Despite a significant change in the embedding space, the difference between deep clustering and manifold-aware deep clustering is mathematically just one term, and thus it is easy to implement and use. In this video, we only show the case of 2 and 3 speakers. However, by considering the nature of regular simplex, our method can be generalized for an arbitrary number of speakers. Actually, in the case of infinite speakers, manifold-aware deep clustering is theoretically equal to the original deep clustering. Furthermore, our method has high practicability for existing deep clustering-based methods. If you are interested in our method or further details, please check our paper or contact us.